Hi, and welcome back to this introduction to dApp development. In the previous episode, we looked at smart contracts and finished off by deploying an FA2 contract to GhostNet. In this episode, we're going to discuss distributed file storage. We'll discuss what it is, how it works, and see some real-world use cases for it. Okay, so let's have a look at the overview for this episode. We're going to learn a little bit about what file storage means, especially distributed file storage. And then we will have a look at IPFS and Pinata, which are two services that we use for distributed file storage. And then we're going to look at a couple of examples of file storage on the blockchain. The first one is storing the metadata for a smart contract, and the second one is storing the metadata and the media for a token. And then finally, we'll just have a look at some considerations that you need to make when you're thinking about file storage. Here we are again at our favorite architectural diagram. And as ever, we're just going to use this as a point of reference so that we know where within the architecture we're looking at today. So you can see down here in the bottom left, episode 7, file storage. And this icon on the left here represents IPFS or a similar distributed file storage solution. The diagram also mentions that our dApp talks to IPFS via the Pinata SDK. This isn't always the case, to be clear, and I will kind of explain the instances when we would use when we would use Pinata and when we wouldn't use Pinata. So for many dApps, we will need to store some data. That might be an image, that might be some metadata to do with FA2 tokens, or it could be anything else. Now, our first option would be to store this data on chain. It seems like the natural place to store anything to do with our dApp. However, as the slide says, on-chain data storage is very expensive. The cost per byte is it would come to about 262 TES for storing just 1 megabyte of data, which as of November 2023 is about $210. That is very, very expensive for storing 1 megabyte of data. So we need a different solution. So instead of storing our data on chain, instead we can find a different solution that is still distributed and still maintains all the advantages and all of the reasons that we want to have our app decentralized. But instead of it being on the blockchain, it is a separate technology, sometimes called destorage, decentralized storage. And the example that we're going to use today is IPFS. There are other decentralized storage solutions, but IPFS is a very common one and a very popular one. IPFS. So what is it? What does it stand for? Well, it stands for Interplanetary File System, which is an awesome name and conjures up all sorts of images of futuristic technology, which it is in many ways, but it is actually very simple at its core. It's a peer-to-peer decentralized storage protocol. And it's very, very cheap, especially in comparison to storing data on-chain. So in IPFS, files are referred to by their hash. So I'll explain this concept in a little bit. But when you upload a file, a hash for that file is generated, and that is the unique identifier that's used within IPFS to identify that file. And what that means, and this is important, is that IPFS URIs are immutable. So if you have the URI for a file that you've uploaded to IPFS, you can know that that file will never change, because if the file were to change, then the hash were to change. So if you are referring to a file on IPFS by its hash, you know that that file is immutable. That is a property of IPFS. And as we mentioned earlier, Pinata is a service that we often use to help us when we're uploading and managing files on IPFS. So firstly, it gives a great UI and also SDK for uploading files to IPFS, but it also provides a pinning service. And what this means is that you can guarantee, if you're using Pinata pinning, that your file will not be forgotten by the network. If you don't pin files on IPFS, then if those files aren't used for a long time, then the network may forget them. But Pinata makes it easy to avoid that. And the final thing to note as well is that IPFS provide their own public CDN. I will show an example of this in a minute, but suffice to say that reading from an IPFS node can be very slow. So IPFS provide a free-to-use CDN on top of the decentralized storage network that makes reading much, much faster. But the caveat is that this CDN is rate limited. So from a single IP address, if you try and make too many requests in a certain amount of time, then you will get rate limited and throttled. Okay, so here we are at Pinata. So what we're first going to do is we're going to upload a file to IPFS using Pinata. They have various libraries and SDKs to allow us to do this programmatically, but it's probably easiest for us to do this through the web UI. So I'm just going to click choose a file here, and I'm going to upload a cool photo of a dog that I just downloaded from the internet. It prompts me to give a name. The name is just for internal management within Pinata. It's nothing to do with how it will appear on IPFS. It's just so that when I'm managing my various files through Pinata, I know which one's which. So it doesn't really matter, is what I'm saying. So I can click upload, and I can always change it later if I want to. And here we are. It's uploaded. You can see here, this is the hash of my photograph. So now this hash will uniquely refer to this photograph on the IPFS network. So if I go to an IPFS node and ask for the file with this hash, it will give me back cooldog.jpg. Now, we're not going to actually directly access the file through IPFS. As I said before, it's much, much more performant to do it through a CDN. With your Pinata account, they will provide you what they call a gateway, which is kind of your own like personal CDN, I suppose, that you can access it through. So if I click cooldog.jpg, that is what it has done. It has given me my own gateway, and this is the hash that we just saw. So I can access it through this, but this gateway is rate limited and has certain thresholds that aren't necessarily suitable for use in production without paying for a higher grade of account. Or alternatively, what we can do, as I mentioned earlier, is we can use the IPFS public CDN, and I'll just get the URL for that now. There it is. And if I hit enter, you can see ipfs.io/ipfs/ this is the hash, my image. There we are. So that is how to upload an image to, or a file to IPFS. Okay, so now I've switched us over to object.com so that we can have a look at a couple of real world use cases of IPFS. So I'm going to go to the Manchester United Devils smart contract on TZKT. And we're going to have a look at the storage for this smart contract. Okay, so now that we've uploaded a file to IPFS, we're now going to have a look at reading files from IPFS in some real world use cases. So here I'm on the Manchester United page on object.com, which lists all of the different collections, also known as all of the different smart contracts that Manchester United have done in the Tezos space. I'm going to choose one of them called Collect United Moments. And I'm going to have a look at the smart contract for that on TZKT. So now, if we have a look in the storage tab, and we have a look at the storage entry called metadata, if I just expand this and then expand this again, you'll see an IPFS URI. And this IPFS URI is all of the metadata about this smart contract. So if I click on this, you can see that what I'm clicking on is IPFS // and then the hash. So if I click on that, I've actually set my browser up so that when I click on one of these IPFS URIs, it redirects to the IPFS CDN correctly. So you may need to set this up yourself, or you can simply copy this part here, the hash, and paste it into your browser with the prefix ipfs.io/IPFS/, which is the CDN that we discussed earlier. But the point is that this IPFS hash gives us this JSON file. And this JSON file contains, as I said, metadata about the smart contract. So here you can see its name, collect United moments, the description, add rare Manchester United milestones, etc. And this smart contract metadata isn't used, is mostly used for indexers such as TZKT and marketplaces such as object.com. So if we have a look here back on object.com, add rare Manchester United milestones and moments, object.com is getting this paragraph from IPFS here. It knows how to read, it knows to look within the storage metadata and then to get that IPFS file and then to read the description paragraph and to display it here. That is part of the FA2 standard. So that is how smart contract metadata uses IPFS. But then probably slightly more interestingly, we can actually see how tokens, NFTs and fungible tokens, use IPFS as well. So if we stay on this same Collect United smart contract, and instead of the metadata part of the storage, we go to the token metadata part of the storage, we can see that there are two entries which correspond to these two tokens that exist for this smart contract. And the first one has an IPFS URI here, and the second one has an IPFS URI here. So I'm going to click on the first one, and it opens up another JSON file. And this JSON file is the JSON file that is the metadata for the first NFT. This file defines what the NFT is. You can see it has an ID, it has a name, Collect United Classic Clean Sheet King, it has a description, and all sorts of other bits of metadata. It also has within it 3 IPFS URIs. So within this IPFS file, there are links to other IPFS files. So if we open those ones, so I'm going to replace the hash in this URL with the hash that I've just copied from here. It gives us an image. So just to kind of repeat what I did there, I'm within this IPFS file, which is a JSON file that is describing this NFT, name, description, but also it has various media links, which are other IPFS files, which are pictures, movies, that kind of thing. And that is basically what an NFT or a fungible token is. It's a JSON file that has links to, it's a JSON file that lives on IPFS that has links to pictures, movies, whatever, that also live on IPFS, and they define what the NFT is. Okay, so here we are back in VS Code. In episode 5, which was the last time that we updated our dApp, we added the ability to display the tokens that user had in their wallet. So let's just remind ourselves what that looks like. So yarn run dev, and it's now up on localhost port 3000. So if I go localhost port 3000 / ep5, then here we go. This was the list of tokens that user owned. But it's not particularly nice because you can't see the images of those tokens, which is really the most interesting thing often about NFTs is the image that is associated with them. So we're just going to we're going to add that, and we're going to have our dApp read from IPFS and display the primary image associated with that token. So this is a pretty simple addition. It's not going to look particularly beautiful, but that's not the point of this. So I'm going to clone episode 5 as I've the convention I've done previously before, and change this to episode 7. So this is a clone of episode 5 called episode 7. Save that one. And underneath where I say the balance of how many of that token that we have and the name of that token, I'm going to add the image of that token. So it's going to be pretty simple. It's just going to be an image tag, and the source of that image tag is going to be the IPFS CDN that we have been using, the standard free-to-use IPFS CDN. And then it's going to be the URI that we're going to be able to get from the TZKT request that we made to get the token's name earlier. So this is https ipfs.io/ipfs/ and then what we need is the artifacts hash. So the artifact is it's an FA2 name that refers to the primary media associated with an NFT. So my use of the word artifact here is FA2 parlance for the main piece of media that's associated with the token. So and this field is available through the same TZKT API that we used before. So before we were grabbing the token's metadata.name, and now we're going to grab t.token.metadata.artifact URI. I'm just going to switch back over to have a look at that Collect United smart contract that we were on before, just so that you can see where this is kind of coming from. So here it is, and let's just have a look again. Going back to, this is for the second token. This was the token metadata for that second token, and you can see here artifact URI has this IPFS link. Now, we want to remove this part of the IPFS URI and just grab the hash, so that we can use the hash at the end of the IPFS CDN URL. So I'll just do something quick and dirty. And this will grab just the hash and append it to this CDN URL. So I'm just going to hit save, and let's see what that looks like. I'm on the wrong episode. There we go. Now we've got a basically null exception error. That's because one of the tokens that is in this wallet doesn't have an artifact URI for various technical reasons. So I'm just going to filter out tokens that don't have an artifact URI. So I can do that by just updating my filter so that it filters out all tokens that have neither metadata nor artifact URI within their metadata. And let's try that again. And there we go. Beautiful. So now our dApp is not only pulling in the amount of each token that we have and its title, but it is also displaying its primary image, which is referred to by the artifact URI. We grab the hash from the URI, and we add that to, we fetch that from the IPFS CDN, and then we display it here. And it's as simple as that. Okay, so as I said in the second slide, we're just going to quickly go over a few considerations that you need to make sure you're remembering when you're dealing with the IPFS, and then we'll be done. So the first one is, as I mentioned earlier, an IPFS node or network may forget your file if it's not frequently accessed. If this is of concern to you, then you may want to pin your files. And Pinata's basic functionality, its core functionality, is that it automatically does this pinning for you. So that's just something to remember. If you don't want to use a service such as IPFS to upload to, if you don't want to use a service such as Pinata to upload to IPFS, you need to remember that you will either need to do this pinning manually, or you're running the risk of the node and or network forgetting your file. The second consideration is that file access through IPFS can be very slow. The basic mitigation that we used against this was using IPFS's public CDN. But if you have a high volume dApp, then you may want to use a different solution. Pinata offer sort of personal CDNs that you can pay for, and that is an option, but you obviously have to pay for it, or you might want to manage these kind of things yourself. There's different options that you can take. And then the final thing is that IPFS URIs, as we mentioned earlier, are immutable. So if you want to update the file associated with an NFT, for example, then you can't unless you also update the IPFS URI within your smart contract. And that leads potentially to the topic of dynamic NFTs. So dynamic NFTs are a concept where the IPFS URI within the smart contract can change. There are pros and cons to this, of course. The pro is that it would provide you an NFT that can change, which can be interesting and cool. But some people don't want that. They would think that that would potentially devalue the NFT because they have no guarantee over what the NFT is going to be in the future. So some people like the idea of dynamic NFTs, some people don't. So different use cases for different situations. And that's it. So all that's left to say for this one is thank you so much for your time. The next episode is episode 8, so there's only 3 left to go. And I look forward to seeing you then. Bye.